Hi, welcome to Cloud Native DevOps for Node.js applications. My name is Abhishek Gupta and I am a product manager at Oracle. Although I do not intend to show you any unreleased product feature today, but I would request you to not make any purchasing decisions based on my presentation. Here is a high-level overview of what we are going to cover today. To set the context, I will start with a general introduction to cloud native applications and DevOps. Then we'll look at some of the basics of Node.js, followed by an example application which involves building a RESTful API using express.js and the Node Oracle DB driver. Then we'll look at Node.js microservices deployed and running on top of Oracle Cloud, and finally a demo again on top of Oracle Cloud, but this time with a focus on continuous integration and continuous deployment of your Node.js microservice. So let's dive in. Cloud native is nothing but an architectural style at the end of the day for building applications to run in a cloud environment. It was pioneered by these consumer-facing web scale, large internet scale companies like Netflix, Amazon, Twitter, Facebook, Uber, etc., whose core business really was technology itself, right? Now the USP of these cloud native style applications is the fact that they can extract, and if designed properly, if designed and built properly, they can actually extract maximum value from what the cloud actually has to offer. And these are things like the ability to consume anything as a service, scalable infrastructure, a viable cost model where you pay for what you utilize, and so on and so forth, right? And the primary motivation behind this style of development has really been continuous innovation and faster time to market, right? And but you have to remember that in order to enjoy some of these benefits or advantages which I just mentioned, you need to keep in mind that some of the design paradigms of cloud native applications are quite different from the ones which you used to develop earlier, or maybe the ones which you still develop within your own data center, so-called monolithic applications, right? So you have to remember or bear in mind that cloud native applications would by and large be distributed in nature. Now that means that there will be multiple instances of your applications running across different virtualized environments, VMs, data centers, or even across availability zones, or even countries or continents for that matter, right? And another key requirement for cloud native applications is the fact that they need to be designed so that they are robust and resilient to any infrastructural issues or changes whatsoever. Okay. And another key thing which you have to bear in mind is the fact in terms of automation, and this includes your continuous integration and continuous deployment pipelines. This is something which we'll discuss in detail in this particular presentation. Now, cloud native applications they often tend to overlap with what are called 12-factor style of development or 12-factor style microservices, right? And again, even this 12-factor style application, they are nothing but a bunch of common guidelines or sort of patterns for these SaaS style applications, software as a service applications, and these were actually compiled. The roots go back to Adam Wiggins and other folks from Heroku as a result of their experiences by working on that platform itself. By the platform, I mean Heroku itself, right? And if you notice, if you notice some of these 12 principles, many of them resonate extremely well with some of the inherent cloud native concepts, such as horizontally, scalable and stateless application, externalized configuration, treating your services like databases, queues as resources, log streaming, and something as common as source code control for that matter, right? And I'll be touching upon some of these topics in the upcoming slides. A common way of categorizing application or service teams is by segregating them into development and operations groups. Now, everything is good as long as there are no issues, but whenever things go wrong, there are things like fingers are pointed, there are blame games, and at the end of the day, um, frustration is imminent. Now, DevOps seeks to actually change, if not all, at least some of this by aligning these previously disparate teams together towards a common goal, right? So developers continue to do what they do best, right? They continue to focus on their strength, which is to develop new features. And the operation teams who have more experience with the actual infrastructure platform, they continue to keep the lights on and work towards keeping the systems stable, fast, available, etc. Right? But the ultimate goal of DevOps is to bridge the gap between these two teams. So by allowing the development teams to get access to the same technologies that the ops team uses, and by letting the operation teams, giving them insight into code, build processes, and giving them access to information which they need in terms of what changes were made to the code, what's coming up in the next release, etc. Right? So these are the kind of um, things which are required to bridge that gap between these two groups in general. Now, this definition has been very conveniently copied from Wikipedia. It's a rather lengthy one, but of course I'll focus on just the key aspects. So I was just talking about the cultural shift which is required to adopt DevOps in general, but from a technical point of view, DevOps talks about this circle, which consists of multiple steps, which include planning your product, coding it, going through the build and test, releasing it, deploying it, and finally operating and actually monitoring it in production, right? And based on the feedback which you get, you continue to develop and add features, etc. Right? If you're aware or familiar with the agile development methodology, you will realize that these are the same things which even the agile mindset or the agile development methodology aims at. Simply put, Node.js is a server-side runtime for JavaScript. It's built on Chrome's V8 JavaScript engine, which is supposed to be one of the best engines out there. Node.js uses an event-driven and non-blocking I/O model, and it comes along with NPM or Node Package Manager, which is one of the largest repositories of open source libraries in the world. Now, some of the benefits of using Node are the first one is if you're already familiar with JavaScript and if you're using it for the front end, then it makes a lot of sense to utilize the same language for the backend and middle tier as well, right? And another key benefit is the fact that Node.js itself is highly scalable and efficient due to its asynchronous operating model. Now, here is an overview of the common architectural paradigm which all the Node.js applications are built upon. Now, the JavaScript code, all the JavaScript code actually runs in a single thread called the main thread. Now, the calls which are made are handled in an asynchronous fashion. So they either end up in a event loop or they are executed within the Node.js thread pool, right? When the operation is complete, the callback function which you had initially supplied would be then added to the event or the callback queue, and they would eventually end up, or rather they would make their way through to the main thread for the execution itself. Now, here is a quick overview of some of the tools and frameworks which are common in the Node.js microservices landscape, right? Now, I have categorized them into four main buckets, which are, REST and HTTP based communication, inter-process communication, basically service to service, asynchronous, messaging based interactions, data management, and then things like, microservices, chassis, or, some of the foundational services, process managers, etc. Right? So let's quickly run through these tools and frameworks. Express.js is actually a web framework, and it works as a foundation for a lot of other web frameworks on Node.js out there. Restify, as the name suggests, it's very focused on designing and building REST APIs themselves. Kraken.js is actually a layer on top of Express.js itself, and what it does is provides more structure and things like convention over configuration. Happy.js is created by Walmart, and it's actually an alternative to Express.js, and it offers a lot of modules out of the box, but just by default, right? Moving to the asynchronous messaging based libraries, the Kafka node and Node Redis are no surprises. They're used for they're actually libraries for communicating with Kafka and Redis respectively. Now AMQP-lib can be used to communicate with any AMQP compatible broker such as RabbitMQ, and again the same thing goes for MQTT as well. WS is actually meant for WebSocket based communication. That's what this Node.js library does. For data management, there are a few frameworks as well, including NodeORM2 and SQLize, which support they commonly support MySQL, Postgre, MongoDB, and Redis as well, right? And a bunch of other databases as well. Node Oracle DB, of course, it's an interesting and open source driver for the Oracle database itself, and you will see this in action in upcoming parts of the presentation. Waterline is actually the default ORM used in the sales framework, and it actually provides uniform API for again accessing databases like Postgre, Redis, Mongo, etc. Seneca and Hydra are the components which form the or provide the capabilities within what is called a microservices chassis, right? So they actually aim to solve some of the common microservices development concerns like service discovery, inter-service communication, health check, monitoring, so on and so forth, right? And process managers are actually required for production grade node applications. I mean, there's no way you can run, it's very difficult rather to run a high quality production grade node application without these process managers, right? So, namely PM2 and Strong Loop. They tend to take care of tasks such as automatic failure handling, controlling the cluster, runtime performance, resource consumption monitoring, etc. Things like that. Right. Now let's double click and zoom into some of the areas or components of express.js itself. Now I'm just going to go through these four modules within express.js because they're very commonly used. They form the foundation of what express.js actually offers, right? So to start with routing, now it is simply the task of mapping client requests which are sent to a particular URI or an endpoint, along with, of course, the HTTP method itself, so get, post, etc. And these are actually mapped to the right implementation or the handler function itself, right? Middleware are nothing but a bunch of, or rather a chain of functions which have access to the request and response context, so that information is available to them, and they can actually mutate this information and invoke other middleware, the subsequent middleware in the chain. Templating engines, again, these are very common. So if you're aware or familiar with the MVC style of doing things, that is the model view controller frameworks. So typically what you have is these template files which template engine actually populate at runtime with the actual values. Okay, and some of the popular template engines which work with Express.js are Mustache, EJS, etc. Now, Express.js also contains a debugging module which is used to internally log information about things like routing matches, middleware functions, etc. Now, the real USP of Express.js is the fact that it is generic enough to cover a wide variety of use cases, but yet minimalist enough to not really obscure developers from the Node.js language itself. Now let's take a look at a simple yet practical Node.js application on Oracle Cloud. Now this is an employee management app which exposes a REST API on one end, and on the other hand it uses data within the Oracle Database Cloud Service using the Node Oracle DB driver. We will look at some of the details of this driver in the upcoming slides. For now, this is how the REST API looks and how it is implemented with Express.js. So we define routes to handle our client web requests, and these routes actually consists of the URI itself, the HTTP verb, and of course our implementation, which is skipped in this particular slide. So we have different operations for our employee management application which map very well with the HTTP verbs. For example, in this case, the post HTTP verb is used to create a new employee. The get verb is used to get all the employee details from the Oracle database. The other get verb, which is a variation on top of the previous one, gives you the flexibility to search based on a particular criteria. Put is actually used to update the details of an employee, and delete, as is pretty evident, is used to delete the employee from the Oracle database. So this is how the REST API looks like when implemented with Express.js. So Node Oracle DB, which is used to interface with the Oracle Database Cloud Service in this case. So this is actually an open source driver for Node.js for Oracle Database, of course, right? It is quite feature rich, and of course, since it is open source, I would encourage you to go and check it out on GitHub as well as on NPM. And just a quick note that this driver leverages OCI, Oracle Call Interface, which in itself is a wrapper, a C-based wrapper on top of Oracle Database. This is how a typical implementation looks like. So in our case, in the case of our employee management application, we implement the get all employee functionality in this manner. So we, using the Node Oracle DB driver, we get hold of a connection, a handle to our Oracle Database Cloud Service, and then we execute our SQL query, which in this case happens to be select star from employee, not surprisingly. And then we iterate over the results and create a JSON payload, which we then finally push to our client. And of course, we follow the best practices and release the connection at the end of our call. Right, so this is pretty simple, and this is how a typical implementation looks like, or a typical flow looks like when using the Node Oracle DB driver. Now, if you recall our discussion of cloud native applications and 12 factors style applications, some of the points which I mentioned, it would be good for you to understand how this application, our sample application, embraces some of those capabilities or some of those points, right? So to start with, it's a stateless application, exposes a REST API, and for persistent state, it uses the Oracle database in this case. The Oracle database itself is consumed as a service, as a declaratively configured service, just just as any other external resources should ideally be consumed in a cloud native world. The application itself is highly available and it is horizontally scalable in the sense that you can add or remove instances as required, and the load balancing would be taken care of automatically by the platform. And you will see some of the you will see this example in action in the demo, which is going to come up later in this presentation. From a configuration standpoint, everything is stored in environment variables, including the Oracle database connection details, and the way it binds to the port, in this case via a $port environment variable, etc. And some of the other parts, which again will be covered in the demo, include the management of the code itself, right? So source code management, as well as the continuous integration and continuous deployment. Now here is a buzzword compliant introduction to Oracle Application Container Cloud. I'll let you soak this in and expand upon some of these points in the upcoming slides. Oracle Application Container Cloud is built to deploy and run 12-factor style cloud native applications and microservices. It is polyglot in nature, meaning it supports multiple languages as well as runtimes, including Node.js, Java SE, Java EE, PHP, Python, Ruby, as well as Go. Your applications actually run within Docker containers, but Docker is not actually exposed or abstracted to the user. Things like container orchestration, scheduling, placement, etc. are taken care of by the platform. You have the capability to vertically and horizontally scale your application. Now, Oracle Application Container Cloud is flexible and open, yet it is very closely and tightly integrated with the Oracle PaaS ecosystem, which means that you can easily integrate with Oracle Cloud Services using Application Container Cloud. Now, here's a runtime view of applications running within this platform. You have complete tenant isolation. And as I said, your applications actually run within Docker containers and you can scale out horizontally, right? But there is this load balancer to make things easier for you. You don't have to configure this load balancer as such. It is automatically going to take care of distributing the load between multiple instances of your applications. And on the right, what's highlighted is the tight integration to the Oracle PaaS ecosystem, as I just mentioned, which includes services like Oracle Database Cloud Service, Oracle Event Hub Cloud Service, Java Cloud Service, so on and so forth. Build, zip, and deploy. Really, this is the simplified mantra of Oracle Application Container Cloud. Now, what does this really mean? In the build part, you would assemble your application. Say for a Node.js application, it would mean npm install. For a Java application, you might say mvn clean install. It doesn't really matter. And then all you really do is convert your application into a zip file. Now the zip file would contain your application, its dependencies, and some deployment descriptors, which is actually encapsulated within a JSON file called manifest.json. And then all you need to do is to push the zip file to the cloud, and you have multiple options there. You can obviously do it through the console, but we have a CLI, a REST-based API, as well as integration to CI/CD platforms, including the one within Oracle Cloud, which you will see very soon. Now let's talk about Oracle Developer Cloud. I hope you remember this illustration from one of my previous slides. The good part is that Oracle Developer Cloud actually helps you through the majority of these phases or stages of this particular cycle. Beginning from the planning stages of a project to the actual coding and the implementation, along with the building, testing, and the release cycle, to of course the deployment to your production, test, or staging environments. The operate and monitoring stages are actually handled by specialized Oracle Cloud services. Now, the functionality or the features of Oracle Developer Cloud can largely be bucketed into two categories. Starting with the code management and the continuous integration side of the house, there is a source code management feature which is largely handled by Git repositories. And then there is build automation for different languages, including Java, for which you can use Ant or Maven or Gradle, and npm for Node, etc. You can also use a generic shell command or talk to Oracle database using SQL.cl. We also have continuous integration engine as well as a deployment automation component built in within Oracle Developer Cloud. Now, coming to collaborative, team-based, agile development, there are a bunch of features in Oracle Developer Cloud for this as well. So, starting with issue tracker, activity stream, collaborative code review, as well as some of the agile development features as well. Now, here is where the entire story really comes together, starting with the moment the developer actually pushes the code into Git repository within Oracle Developer Cloud, and then it kicks off a build and zip phase within, again, Oracle Developer Cloud. And then the continuous integration and deployment engine kicks in, which finally pushes the application to its deployment platform. In this case, it is Oracle Application Container Cloud. Alright, let's look at a demo now. Right now, I'm in the landing screen for Oracle Application Container Cloud. As you can see, I have my Node.js application deployed over here. The Node runtime version is 8.1.4 to be precise, and here is the URL of our application. Now I'm going to click on the name of the application to go into the details section here. As you can notice, here is an overview of our application. We have two instances, one memory of GB allocated to it. We can scale this up if we wanted to. I'm not going to actually do this right now. And we can also scale this out to say 3 or 4 or more instances. I'll say cancel for now. Moving forward, if you notice, we have again the details for each of these instances. They are labeled web.1 and web.2 respectively, and here are their memory consumptions. If we move into the deployment section, we will see some more details associated with this particular application. So basically, some of the things which we see here are the archive name. This was the name of our zip file which we deployed to our application container cloud, and these are the contents of our manifest.json, and I'm going to show this in the demo after some time. So this is our launch command to bootstrap our Node.js application, and the topology, as I said, 2 instances and 1 GB of memory. The interesting thing to notice here is the service binding or the dependency declaration on Oracle Database Cloud Service, which is named quite interestingly. Um, my name pronounced in reverse, basically. Um, so this has been explicitly declared within deployment.json so that Oracle Application Container Cloud can bind to this database cloud service instance at runtime and be able to invoke its various functionalities like uh, checking data from the table, etc. Here is the database cloud service instance which I was just talking about, right? So we are right now in the Oracle Database Cloud Service landing page. Now let's run our application. So as I said, this is the publicly accessible URL for our employee management application. So if I click on this right now, if you notice, this is our application which just got open. It's a very simple one, not really flashy, but hopefully good enough to explain the point in terms of its integration with Oracle Database Cloud Service as well as some of the other cloud native aspects which we previously discussed. So here are a bunch of employees which are seated within the database right now. We should be able to see the details for them, for any of the employee for that matter. Now let's go ahead and add a new employee. Abhishek, birth date, title and department, and I'll say add. Okay, so looks like this was successful, and here are the details which were entered. Now let's go back to our database and query it to confirm that this indeed got pushed to Oracle Database Cloud Service. So let's give it a few seconds for the database query to get executed, and then we should be able to confirm that the record indeed got seeded within our database instance. Okay, there seems to be a minor hiccup, but I think it should be. Oh, all right, never mind. So if you notice, the exact same records which I entered the new employee details were in fact pushed to the database. So why don't we go back and delete this employee right now? So Abhishek Gupta is going to be deleted right away. So I hit the employee name and I say delete. Say OK. Alright, our view is refreshed, our Node.js application view, but what about the database? If I hit refresh, so okay, if you notice this time around that the employee in fact got deleted from the database. Okay, so now that we have looked at ACCS, Database Cloud Service, as well as the application demo, let's move on to the CI/CD side of things, that is continuous integration as well as continuous deployment using the integration between Oracle Developer Cloud and Oracle Application Container Cloud. So to begin with, let's make a change to our application. So if you already saw that the header here, or not the header, the main title here is Cloud EMP app. Now let's go to the index.html and change things up a bit. So I don't like this, so I'm going to change this to something better. So Cloud Employees Application, and what's up with these people anyway? So they are employees, so let's change that as well. Now that we have made this change, let's push it to our Git repository in Oracle Developer Cloud, and I'll show that to you in the next part of the demo. But for now, just understand that I have a project set up within Oracle Developer Cloud which has a Git repository which hosts this source code. Okay, so let me first commit this. updated landing page message, and we do a git push to the upstream repository as I mentioned earlier. So let's give it a few seconds, and there you go. Our change has indeed been pushed. Now let's move over to Oracle Developer Cloud now. Here is the landing page of Oracle Developer Cloud Service, and what you see here is the top level project, which is aptly named Oracle Code Demo Project. And if I go into this project, what you now see is the landing project page, which highlights in a timeline style all the activities which have been executed on this particular project. Obviously I have done my homework, so obviously you see that I've done a lot of testing and activities on this particular piece of demo. So that's that. In terms of the code itself, I was just talking about this a few seconds back, that there is this Git repository. Oh, let me just go back and highlight this as well. So this is the Git repository I was talking about, node app.git in this case, and this is natively hosted within Oracle Developer Cloud Service. This is not an external Git repository as such, although you have the ability to import from external Git repositories directly into Oracle Developer Cloud. Coming back to the code section, slight delay there, my apologies. So this is the code here. So it consists of the server.js, which is our Node.js business logic, along with, of course, our Express framework, and our static pages, that is our index.html, etc. And this is the one which we had just updated. And if you remember the commit message which I had mentioned, updated landing page message, so this is the change which we actually just made, right? So this was in fact pushed back into our Git repository. And as I mentioned earlier, Oracle Developer Cloud Service has two main components. One is the code repository as well as the CI/CD engine, and the other is the collaborative agile based team development capabilities. So the issue tracker, the agile dashboard, as well as this wiki are a part of that particular agile development and the collaborative team development capabilities within Oracle Developer Cloud. Now let's move on to a couple of important sections which are very important from a CI/CD, continuous integration and continuous deployment pipeline, which I'm trying to highlight through this demo here. So let's go into the build section. So if you see, there is a build job called node emp-build, which I had configured. And if you see, it in fact got triggered 3 minutes ago, which was not very long back. And this actually was as a result of me pushing that code into the Git repository, the one which we just updated. So if I go into the configuration for this particular build job, you will see why that happened. So this is the main page where we define the name, the build parameter section not being used, but it's interesting nonetheless. The important part is the source control. So here is where we link our build job configuration to the Git repository which I just mentioned some time back. And here is the trigger section. So what we have done here is configured Oracle Developer Cloud to poll our Git repository at regular intervals, so that if there is any update, this particular build job would automatically get triggered, and that's what happened in this case as well. And I'll prove that to you in a second. Moving on to build steps. In our case, we are executing two steps as a part of building the package for this particular application for deployment on Oracle Application Container Cloud. The first step is npm install. It pulls all the dependencies from npm, of course. And finally, here is this execute shell command to zip up all our application related dependencies into one uber zip called app.zip. What do we want to include in this zip? Is of course our Node.js module, our static code, which includes CSS and HTML, our node modules folder, which got created as a result of our npm install, and our package.json. So all these contents would be bundled into this zip and finally deployed to Oracle Application Container Cloud. Now, coming back to the topic of our build job execution. So if you notice here that the update which we had pushed actually resulted in the trigger of this particular build job, the one which I just demonstrated to you, right? Now, if we go into the deployment section, this is the component which is configured within Developer Cloud, which is actually responsible for pushing this application zip file into Application Container Cloud. Now let's look at some of the details of this configuration. So I'm going to say edit configuration just to show you some of the details here. So these are the properties or the details of the Application Container Cloud instance. In this case, it is one of the instances which I'm using, of course. And we have a couple of options in terms of how this deployment itself will get triggered. So in this case, I have chosen on demand on purpose so that I can demonstrate some of the capabilities to you. We could have chosen automatic, and then what would have happened is that this deployment job would have gotten triggered automatically right after a successful completion of the build job, right? But in this case, I want to trigger this manually. So the on-demand choice in this case. This is the name of the build job, which I just showed to you. And let me choose the latest build artifact so that it contains our updated code, our updated logic, right? And that's our artifact app.zip. And this is the manifest.json, which I was referring to earlier, right? Which has the bootstrapping command and the rolling deployment mode. And I'm going to talk about this in a second here. And here is our deployment.json, which talks about the binding as well as the topology. In this case, it's 2 instances and 1 GB of memory. So when I say save and deploy, what it will do is trigger an update to Application Container Cloud. If you notice here, it says deployment started just now. So if we go over to Application Container Cloud here and hit refresh, you would notice very soon that a new release deployment has been initiated right now. So if we go over to this side of our application, you would notice here in the in progress activity section that a new instance, a standby instance of our application is being deployed. Now, what's the deal with the standby instance? If you noticed that within our deployment configuration, what we had was the mode was set to rolling. What that means is that we have 2 instances here, but not all the instances, not both of these instances will be brought down together to ensure that at least one of our instance is live and serving traffic for our end users. So essentially, what would happen is that the deployment update process would be slightly lengthier, but then our uptime will be higher, or 100% in this case, because our application will never technically be down. So if you notice, application container cloud spawned standby instances of this particular application just so that our end user experience does not get affected. So if I invoke my application again, so you see that the deployment is still happening, but our application is still live, up and running, ready to serve traffic. Once this entire cycle is completed, by that I mean that both our application instances, the new ones, are up and running, we would continue to see the older version, but our application will be live, right? So if I hit the application now, if you notice, now we have the new version of our application deployed completely, and this is evident by the change in these two messages right here. Now it says cloud employees application and employees instead of cloud emp app and people over here. And at the end of the day, these were the set of processes which were executed. I'm just repeating for your convenience. So what application container cloud did was to spawn standby instances for your application and finally roll them over to new set of instances, just so that our uptime is 100% and our application is always live. All right, that's all I have for you in this presentation. Before I sign off, I would like you to check out these resources, including Oracle developers, on Twitter as well as Medium. Thank you and goodbye.